Hello everyone, welcome to this brand new series of tutorials on how to build your own robot using the ESP32 from scratch. Whether you're a complete beginner or someone with a little bit of experience, this course is designed to guide you through the entire process step by step. Today's video is introduction and I'll be talking to you about some key aspects about this course. Now, before we go any further, I just want to let you know that I respect your time and I'll try keeping these videos concise and to the point except for this one. Now, what are the prerequisites? Firstly, the only real technical skill you need to have is a little bit of soldering experience. If you're new to it, no worries. Now on to coding, you'll need some basic Arduino skills. Although I'll be teaching you how to code from ground up, you still need to know a little bit of basics so that you don't get lost. Who is this course for? If you're someone who wants to start robotics, then this is the course for you. The level of the course is primarily designed for somebody who's building their first robot. It doesn't matter if you're in high school or university, as these tutorials are well structured and detailed. So what are my expectations? To get the most out of this course, I expect you to put in the work and go through the challenges I set for you. Real learning happens only when you solve challenges on your own. And the more you struggle solving these challenges, the better the learning. Secondly, I would say do not binge watch these videos as information needs to be consumed in small chunks. Alright, let's talk about the roadmap. Now, the very first thing we'll be installing is the IDE itself. We will then be installing the necessary drivers based on the chip you have on board. Now, these drivers are required for the board to communicate with a laptop or PC. If all goes well, we can then start learning how to program. I will be starting the basics. Now, if you're already familiar with the C language, you might find this easy. We will start with macros, and then I'll show you a better way to do it in C++ using const expressions. We will then play around GPIOs, where you will be learning how to turn the GPIO pins high, low, and also learn to build pull-up and pull-down circuit. Talking about data types, we will be using data types from the standard int library, and we will go over the basics of memory, variables, how to generate fast and slow PWM signals using the LEDC library. Talking about serial communication, we will be learning about UART and how to communicate over UART using the inbuilt serial library. And also we'll be exploring Bluetooth and using it to control the speed and direction of the robot. After all that, finally we will start with functions where we will be programming the front, back, left, right, and a whole lot of other functions. At reaching this point, you will be having a complete working model of the robot, but with spaghetti code. So don't stop here. This is where you need to go back and start refactoring your code and cleaning the code base. By doing so, you'll be giving structure and readability to the code base. And the way you are going to achieve that is by implementing state machines, classes and objects, and segregating the code between different files. This is the actual robot we will be building. The dimensions of the bot are 25 centimeters in length and 20 centimeters in width. Once you decide on the dimensions, the next thing you want to choose is the wheel diameter. Now, I like to use massive wheels that can cover as much as surface as possible with 1 centimeter gap in between. So I went ahead in choosing 12 centimeters as my wheel diameter. Now let's talk about the inner chassis. The inner chassis consists of two PVC tees of 4 centimeters in diameter and a long PVC pipe connecting the two tees. The long PVC pipe also holds a 2200 mAh battery in the middle. Now you might be wondering, why are we using PVC build? It's just because everybody doesn't own a 3D printer and we want to keep the cost down. Plus there are a lot of pros in using the PVC, which I will get into in another video. The motors go in there from the sides and the wheels are connected to the motors through the shaft. Also, the circuit sits on top of the battery. Now, I did not start with a perfect design. My very first design build was literally like this. I was using an Arduino Uno, an L29810 motor driver with an HC05 Bluetooth module. This was possibly the worst setup ever, as the L29810s are super inefficient as they dropped 2 volts. So for example, if I had to provide 12 volts to the L298 motor drivers, they would give an output of only 10 volts. So 2 volts would be dropped or they would be converted into heat. So it was a pretty bad setup. Now moving on to build 2, as you can see, I started incorporating triangles in my design in order to have a sturdy design. Build 3 is more of an experimental build, as I was started to experiment with trusses, which is a geometric design used in designing bridges, and it is also a chain drive. The setup is pretty unreliable as the chain kept on falling, and the setup had alternate motors and alternate dummies, so it also had torque issues. By build 3 iteration 3, you can see that I've upgraded from the L298N motor drivers to the MOSFET based TB6612 FNG motor drivers, which are super efficient. And in terms of the design, I switched to a mechanism wheel based drive. Talking about build 4, you can see that the PVC design is coming into action, and by iteration 2 I replaced the mechanism wheels with buggy wheels as I wanted to make it an off-roading all-terrain robot. Now by build 4 iteration 3, you can see that I've converted it into a full-fledged Cybertruck buggy, and by iteration 4 I removed the Cybertruck frame as I wanted to continue driving it when the bot topples upside down. This helped me in a few competitions. This is the current and the final build of the robot, which we will be building throughout the course. It has an OLED panel on it, which we won't really be integrating as it increases the complexity. The bot also has a really cool hinge that one of my friends designed. Apart from that, we will be taking a look at how to control the robot using a smartphone. Android or iOS doesn't really matter because we'll be using BLE to do so. We will also take a look to how to interface the robot using one of these. It's a FlySky RC controller. You don't need to have the exact same model. You can have any FlySky controller to control the robot. And if you don't have that, then that's completely fine. You can continue using the smartphone. And if time permits, we can also take a look on how to control using this PS3 controller. Moving on, let's talk about the components. Please check the description below for the link. It should take you directly to my page on GitHub where you can see the list of basic components. If you aren't seeing this list, then you can click on branches and check out the 00 introduction branch, which will take you to this page which says basic components. Later in this course, I'll be adding more branches like 02, 03, which will give you access to more resources like code snippets, challenges, and a lot more other stuff. When it comes to the components, I don't want you to buy all components required for the build. Instead, what I want you to do is to buy the basic components to get started with, and I want you to watch a few videos to find out if you're really understanding the concepts, and only if you feel confident enough working with the basic components, you can then invest in buying the main components. You might be wondering, where are the main components? If you scroll back up and click on the branches and check out the 01 main branch, you will have access to the complete list of the components used in this series. It also includes the mechanical components. So let me go back. Again, I repeat, do not buy the main components until you have finished the beginner lessons with the basic components. Now let's take a look at the basic components. The one with the tick mark are the recommended ones, and the ones without the tick mark are the alternative links. So for example, if you click on the one with the tick mark and it says out of stock, only then you go ahead and order the one without the tick mark. All right. The total cost of the basic components is roughly around 600 rupees if you buy online. This is like a one-day trip to McDonald's, so I think it's a good investment if you want to get started with electronics. If you ask me when is the right time to buy these, I would say right now, and it should be even cheaper if you try getting these from your local electronics store. Let's take a look at the basic components in detail. First up on the list, we have the good old ESP32 room module. It has inbuilt Bluetooth, Wi-Fi, and that's the reason we are choosing it over the Arduinos. Now, if you take a look at the ESP32 that we will be getting for this course, this is the 30-pin version of the board and not the 38-pin version. So just in case if this runs out of stock, make sure that the ESP that you're getting has 30 pins. It will be clearly mentioned on the description if it is a 38-pin. So make sure you don't get that and you find another board which has 30 pins. Moving on, get the micro USB cable which connects your ESP to the computer. Talking about breadboards, we'll be getting two breadboards. Now, the reason why we'll be getting two breadboards is simply for the fact that the breadboards, the ESP32s, are not breadboard friendly. As you can see, we can only access one side of the GPIOs through only one column, and the other side of the GPIOs is inaccessible. So the form factor of the ESP32 is not breadboard friendly. So what we will be doing is we'll be breaking apart the breadboards and combining two breadboards to form a larger version of the breadboard, um, which gives you access to more columns on either sides. Okay, get two LEDs. I mean two colors, but get two of them. So just in case if you lose one of them, then you don't have to go and order again. So get any two colors of your choice. I have suggested red and blue, so it doesn't really matter. Okay. Get a resistor kit with multiple values. Later in this course, I will be going over how to calculate the right value of resistor for a given component, so that might come in handy. Next, we have the jumper wires. Get male to male ones, and I think set of 10 should be enough, but if you go out there and buy a set, then it usually consists like a set of 40. Get the tactile switch. Now, we will be learning important concepts using the switch, such as interrupts and state machines, so get the tactile switch. When it comes to buzzer, there are two types of buzzers. There is an active buzzer and a passive buzzer. Now, what I wanted to get for this course is a passive buzzer. So how do you know that, or how do you differentiate between an active and a passive buzzer? Although they look identically the same, the only way you can differentiate them is by taking a look at the bottom side of the buzzer. If it is exposed like this, then this is a passive buzzer. And if you take a look at the active buzzer, it is usually covered with some kind of a resin. So if you go and buy this in a local store, make sure that your buzzer is looks something like this on the bottom. Okay. Yeah. And lastly, we have the 2N222A NPN transistor. Now, you cannot connect the buzzer directly to the GPIOs because the buzzer might end up pulling more current than the GPIO can provide, leading to the GPIO completely getting destroyed. So we will be using a 2N22 to a NPN transistor to drive the buzzer. And if you're wondering why we have it, so that's the reason. So this is the list you need to get first. And in the next video, we will be talking about the main components. So if you just scroll up here, we'll be talking about the main components. As this video is getting long, I would like to conclude here. Lastly, I would say that when I was starting out, I didn't have a lot of help, so I had to resort to trial and error. It took me a very long time to learn the beginner concepts, and it's very easy to get stuck and waste your time learning the wrong things. This set of videos is to get you started as an embedded systems engineer, robotics engineer, a hobbyist, or whatever you want to call it, and aim you with the right information so you can get moving as soon as possible. But your aim should be to branch out from here and learn more advanced concepts like implementing FreeRTOS, learning how to program using the IDF, or a whole new microcontroller altogether like the STM32s, or even learn embedded Linux. But keep in mind, you want to build solid projects while learning, or else it's wasted potential. The path is long and resources are abundant, only if you know how to find them. Until then, I'll see you in the next one.